In this video, I'm going to go over alkenes. So the process is very similar to naming alkanes. We need to find the parent. But now we have to number the carbon chain in such a way as to include the alkene in that longest carbon chain. Okay. So we would not number the carbon chain this way. 1, 2, 3, 4, 5, 6. Because that longest carbon chain does not include both of the carbons in that alkene. You need both of those carbons. So we have to number it the way I did it here. So we see that is parent name, there's 6. So that would be hex, not hexane, hexene. Now, what are the substituents that are coming off of that carbon chain? Well, we have an isopropyl, and we could call that 1-methyl ethyl. And then we have 2 chlorines, so a dichloro. So we've got all our substituents numbered, or named. Now we have to make sure that how I numbered this carbon chain is correct, because I could have very well have done it this way. All right? Could have numbered it that way. So how do we number this? Well, let me read the bullet point. It says, for a chain, carbon 1 begins at the end that allows the carbon double bond to be encountered the earliest. If there's a tie beginning from each end, then break the tie using the rules from what we've learned from the alkane chapter. To minimize the locator numbers for the substituents. So I did not read that very clearly, so let me read it again to make sure we have this. Okay? For a chain, carbon 1 begins at the end that allows the double bond to be encountered the earliest. If there is a tie beginning from each end, then break the tie using the rules from the alkane chapter. And those rules state to minimize the locator numbers or locants for the substituents. So in this particular case, we see in the green numbers we bump into our alkene at carbon 4. And in the blue numbers we bump into our alkene at carbon 2. So based off of that first bullet point, it said we want to give the locator number priority to the alkene. So that means that's how we number it. So our isopropyl, or our 1-methyl ethyl, is at carbon 3, and our dichloros are at carbon 4. And now we just have to put this all together in alphabetical order, right? C comes before M. So we would name this guy 4,4-dichloro 3,1-methyl ethyl. And then what's our parent name? Hexene. Now, that is not the correct name. I'm missing something. What I'm missing is, where is that double bond or that alkene? And there's 2 ways that you can do this. Okay? The one way is to, right before the ene suffix, put the locator of that alkene. Like that. Hex 2-ene. That tells us where that double bond is. Or the second way is to put it before, let me just show you. You would go 2-hexene, like that. So you can put the number before the root or in between. Okay, so both would work. Perfect. Okay, same process. You need to find the parent. Longest continuous chain. So I could go 1, 2, 3, 4, 5. I need to include the 2 carbons in that alkene. But could I have numbered it 1, 2, 3, 4, 5, 6? Yes, I could. 6 is greater than 5. So we have a hexene. So that's 1, 2, 3, 4, 5, 6. There's our longest parent chain. So our substituents are a methyl and a nitro. So now we need to number this in the appropriate way. 1, 2, 3, 4, 5, 6. Versus, what if we did it in the opposite way? 1, 2, 3, 4, 5, and 6. Okay, this is interesting. Because in the blue numbers, when do we bump into our alkene? That's what we're trying to do. We want to give the alkene the lowest locate number. In blue, we bump into it at carbon 3. In pink, we bump into it carbon 3. So we have a tie. Okay? So let's go back to the bullet point here. I've read this already, but it's good to read it again to hear it. For a chain, carbon 1 begins at the end that allows the double bond to be encountered the earliest. If there's a tie beginning from each end, then break the tie using the rules from the alkane chapter to minimize the locator numbers for the substituents. Okay, so if I go in the blue numbers, when do I bump into the first substituent? The methyl is on carbon 3. But if I number in the pink, when do I bump into the first substituent, the nitro group? Carbon 2. So we just broke the tie using that rule. So that would mean the pink numbers right there helps us break that tie. So that means our nitro is at carbon 2 and our methyl is at carbon 4. Now we put that all together in alphabetical order. M comes before N. So that is a 4-methyl, 2-nitro. And then we have hexene. So we could do it this way. We could go 3-hexene. That's one way to do it. Or we could number it this way. 4-methyl, 2-nitro, hex dash 3-ene, like that. Both are acceptable. Both are 100% right. Just different ways of doing it. Let's take a look at a cyclic alkene. Now let me read you the rule for how to approach this problem. For a ring, the carbon atoms of the double bond must be carbon 1 and carbon 2. It has to be carbon 1 and carbon 2. Or it could have been carbons 1 or 2. That's the rule. You have to pick either the blue or the pink. Now, how do you know which one to pick? Blue or pink? Let's keep reading here. So for a ring, the carbon atoms of the double bond must be carbons 1 and 2. Which of those carbon atoms is carbon 1 is determined by the rules from the alkane chapter to minimize the locator numbers for the substituents. So if we go in blue, okay, 1, 2, 3, 4, 5, 6. When do we bump into our first substituent? Carbon 4. But if we number it in the other way, 1, 2, 3, 4, 5, when do we bump into our first substituent? Carbon 3. So we break, that's how we break that tie. So I kind of jumped ahead there. I kind of didn't put our parent right here. Our first step is to find the longest, if there's a double bond within the ring, then that's going to be the size of the ring, right? So that's going to be a cyclohexene. So that's our parent name. And then what are the substituents coming off of that parent chain? That right there is a methoxy. And then we have our dichloros. Now getting into out and numbering the chain here. That's going to be in the pink numbers. And we see that the methoxy is at carbon 3 and the dichloro is at carbon 5, 5, 5, like that. And now we just put it all together. C comes before M, so 5, 5, dichloro, 3-methoxy, cyclohexene, like that. Now, why do I not need to do this? Like that. Why do I not need to specify where that double bond is in the name? Because of the bullet point rule. The first bullet point says, the alkene in the ring has to be carbon 1 and 2. That's just the rule. So we know that. So we do not have to specify where it is in that parent name because it's implied. Let's do another one. So what's our parent? So let's count the longest carbon chain here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Okay. So 1, 2, 3, 4, 5, 6. Same thing. So it looks like, what if I tried this carbon? 1, 2, 3, 4, 5, 6. So it's all getting 6. So that would be a hexene, right? Now what's coming off of that parent chain? I have a methyl here. And then I have those 2 methyls there. So we have 3 methyls coming off of that parent chain there. So we got the parent, we got the substituents. Now we just need to number that parent chain in the appropriate way. So what if I did it in the opposite direction? 1, 2, 3, 4, 5, 6. Remember, our first goal is to number it to give the alkene the lowest locate number. So in the green numbers, it's at carbon 3. And in the pink numbers, it's carbon 3. So we have a tie. How do we break the tie? Looking at the substituent that we bump into. Okay. So in the green numbers, we bump into our first methyl substituent at carbon 2. And in the pink, we bump into our first substituent at carbon 2. Got another tie. Okay. So then it's like, okay, let's bump into the second substituent with the lowest locate number. And if I call that my first substituent, my second substituent would be that guy. And I see I bump into that in carbon 2 in the pink numbers versus 5 with the green numbers. So that means our pink numbers win out. And so this can all be combined, right? Because they're all the same substituent, just at different locations. So we have a 1, 2, 5. How many are there? 3. So we have to go try. And what are they? Methyls. There's no alphabetizing here because there's only one type. So we just put it all together. Okay, now I made one mistake here. Those are the substituents. Both of them are on carbon 2. So it's a 2-2, yes. And then that methyl is on carbon 5. Now we'll put that all together. 2,2,5 trimethyls, or methyl, sorry. And then hexene. Now we can specify where that triple bond is, and that's at carbon 3. That's how you name it. Or like that. Both would serve you well. Alkene here. It's not showing up the best, but you can still see it. It's not the brightest, my apologies. So the parent, that would be cyclohexene. That's the 6-membered ring. Now what are substituents? We have dimethyls. And then we have 1, 2, 3, that's a propyl. Now how do we number this thing? Is it 1, 2? Because the double bond has to be carbons 1 and 2. Or is it going to be 1 and 2? Well, how do we break that tie? We just want to bump into the substituent with the lowest locate number. So we have a substituent that's directly attached to that double bond. So we want to give this substituent the lowest locate number. So we would give that number 1. So 1, 2, and then 3. So we have a 3, 3 dimethyl, and then a 1 propyl. You know, we just have to alphabetize that. M comes before P. So we would just go 3, 3 dimethyl dash 1 propyl. And then we tack on the parent name there. Cyclohexene. Just like that. And that would be our correct answer.